actually at the same time, here, T2 can actually happen because we have a token in this P2 as well, right? So which action takes place first? Randomness, right? So that's randomness. So that's essentially internet. You both of you guys on two different computers trying to register for the same class, one person got in, the other didn't. Haha, that's actually T1 and T2. T1 passed, T2 didn't. Sorry, right? Randomness in our system. So this would be a nice notation for you to actually capture things like concurrent execution, deadlock, risk condition, better way for analysis to happen. This is essentially finite state machine as well. Just different notation, different way to say the same finite state machine. All right, that's going to be our discussion on the PatriNet. Then you have another approach called Z. Some people on our faculty actually you used to do research on this, not anymore. So essentially, the idea is you define a system by sets. So basically, every state is a set. So every state is a set. Your action is also basically operating on sets. Okay? So for instance, your button state's going to be a set. Then you have conditions. Conditions, you actually say floor button plus elevator button equal to all buttons. And floor button and elevator button have no common, have no intersection. Okay? So essentially, you define conditions by predicates. I mean, you condition predicates by defining the set. Okay? So in this, why this is useful? Because you don't want to enumerate all the state machines, because that will be too many. So you, instead of enumerating each state in the state machine, you basically say, I'm going to summarize all the state into sets by using predicates. That essentially is that approach. Say this is like algebra. This is algebra in computer science per se. So for instance, in our grade school, I mean for my youngest son in the before pre-kindergarten, if he can count from 1 to 10, wow, he graduates right into kindergarten, right? In kindergarten and first grade, you are probably counting to 100. You are able to add 1 plus 1 equal to 2 and so forth. You graduate. I mean, our mathematics foundation is so weak, right? Basically that's it, right? Well, that wouldn't be a scalable approach, right? So sooner or later we need something more. If we just let the kids count as much as they want, I mean, they count all the integers, they can't, right? Eventually we need something more abstract. Then we invented something called algebra. Instead of say enumerate all the possible 1 plus 1, 2 plus 2, and so forth, we come up with something called A plus B, right? That essentially is our foundational algebra, right? Instead of all the concrete thing, we just enumerate. We just use variable. We introduce some concept called variable. Same thing happened here. Instead of enumerate all the possible state the button may be in, we just define characteristic of these states and summarize them together. That's essentially changing from counting concrete number 1 to infinity into just say, okay, I'm going to use a variable A to represent integer. Same thing, algebra. This is essentially algebraic operation, representation of our state machine. Okay, as long as you understand that mapping relationship, that will be sufficient. Okay, you don't. For instance, in your case, in your code, you define variables. You don't really. Why you do loops, right? Why don't you unfold all the loops? It's not efficient. Loop is abstraction. You can repeat it 100 times. If you use a loop, maybe 10 lines of code. even less than that, say 3 lines of code. If you are going to unfold your loop into sequential code, then you are going to have 300 lines of code. That is when you have a limited bounded loop. What if you have an arbitrary large loop, which are going to loop according to user input? You can't unfold all of those things. Just like in studying mathematics, you cannot enumerate all the numbers. So we basically say we introduce variable set conditions. All right, so that will be it. There are many other formal methods. So here is a comparison, and this is something we should spend a little bit more time so that you have an idea. So mainly here, what we are using is called informal methods. Even in your design documents, it's not formal. What you gave me is your class definition, class diagram, how you realize your scenario of use cases, how you realize all the use cases. It's me or my project manager who have to go there, look at your documentation and say, Shirish, did you do the good job or not? Yes, you did, so we give you 4 points, right? Out of 4, but that's what I mean, right? So I have to go, some human being have to go there and look. Why is that? Because it's informal, right? Once it's informal, computer is totally confused, right? We can use computer to look at your document, but it's still us making the decision. Okay? That's why this is very easy to learn and use, and you can easily write your document. You can easily, and for instance, many of you still prefer to write your homework instead of type your homework or so forth, right? Because easy, right? Ready to go. Anytime, anywhere, I want to work on the homework, I can do it, right? It's easy to do. However, the downside is you cannot analyze that. You immediately have to introduce a human being into the process. That's why we cannot scale this class bigger and bigger and bigger, arbitrarily bigger, right? If we have all students sitting here, all the chairs full, I mean, it will take me a long time to get back to your assignment, right? Simply because there's no way to duplicate human beings easily, right? Not yet. So in that case, the informal methods are really easy to use. Almost everybody knows, can do. However, they are not very powerful in terms of easier to analyze by computer. Formal method, on the other hand, is the other way around. Formal method is very hard to use. Okay? I skipped all the discussion about mathematics. Just give you a teaser of they are based on mathematics like algebra, right? Set theory, state machines, Turing machine, right? I think most of you guys are still confused by Turing machine, or not haven't even studied through Turing machine, right? So essentially, if we go there, we have to keep you guys in school until you are at least 30 years old, at least. Okay? So basically, we have to get you in college by 18s into computer science and educate you for 12 years straight to be a reasonable engineer, understanding all the formal methods, understanding a particular formal method, not even all. That is not scalable. That is not scalable. That's why right now we can have your degree ready to go 4 years instead of 12 years, right? But I mean, in that case, you have a very powerful tool, but very few people can build it, can use it in the right way. Actually, that kind of method should be applied to Boeing 737. Why it's not used? Cost. So they were talking about FAA now don't even have engineers to certify Boeing's code. Basically, they ask Boeing to basically certify themselves. Then when people ask why can't you just have government employees and engineers to certify their code, the answer is you need to give me $1 trillion to set out the workforce. Okay, all right, $1 trillion, that's not a small number, right? So we know that's probably not going to be happening, because if you apply all these formal methods, setting up the workforce and everything, education, the cost is very high. And hopefully, you only have a limited scenario when you have to use formal methods. This is powerful tool, very powerful tool. Most of the time you don't. For instance, for our class project, no. If you apply formal method, you're not going to be able to finish my class even before you write down some of the formal definition, right? Actually, a lot more. Actually, what people are using today are mainly the informal methods, right? Use cases. Can you say use cases formalized? No, it's basically still a natural language based representation. Your analysis model, your design model, yeah, still. But once it becomes code, actually it's formal. The code, once you run on the machine, it's actually formal. In the sense that it actually has to be precise enough to run by a computer. But your documents, can anybody find a computer that once you spit into a document and it's running the program? No. That is the gap where you guys sit, right? So essentially, mainly we are using informal methods. What is the trade-off? Productivity and efficiency. Formal methods is great, very costly. Informal method is unreliable, however, it's very efficient. Very efficient. You can produce code quick. Produce code really quick, right? Right now, if you're running Python, yeah, very quick. JavaScript, very quick. Construct a website, fairly quick. Like client server code, like you guys are doing for Socket, very quick. I want you to prove that your formally your code is working, yeah, not this term, not even this year, okay? That will take multiple years. To just prove a small algorithm you guys write in my class will probably take a PhD several years. Okay, that kind of efficiency is not acceptable for practice of the kind of program you guys doing. If this is for 500 lives, it's probably worth it, right? But yeah, still cost is a main factor here. Okay, so that is something to keep in mind. That's why when you see an accident like Boeing 737 software problem, you shouldn't be surprised. You shouldn't be surprised. That's why next time when you step into a closed aircraft, you should be worried. Not say scare you guys off, but yeah, you're really at mercy of both not only the human pilot, but also the software engineer sitting somewhere in a basement. Okay, so this is the comparison. Natural language is very informal, very easy to use and learn and everything, imprecise, ambiguous and contradictory or incomplete. You have some relationship-based modeling, semi-informal, can be understood more precisely, not as precise as formal method, but it can actually give you a little bit of, clear up a little bit of ambiguity, right? Then you have really formal method, very precise, can reduce fault, can reduce development cost and effort in some cases when you really find bugs, but it's actually very hard to develop and team to learn, hard to use, and almost impossible for most clients to understand. That's why, your airlines, they don't know formal methods. Say, okay, just give me a fuel efficient aircraft that can fly, right? It's your job to get it right, not my job. I just need the aircraft to carry my passengers. Do they understand the formal method is like state machine, based approach to model that piece of control software and get it verified, they don't understand, they don't care. Okay? That is the difficulty trade-off. Basically, how much would be the cost we are willing to pay if something fails? All right? There are always many approaches that are coming up. So this is, in software engineering, you never actually stop learning new things. Things popular today are not going to be popular tomorrow. For instance, ML and AI is fairly hot. Who knows whether it's still hot 5 years later, right? Hopefully still, yeah. So the software engineering, the basic fundamentals still the same, right? So still the same. You have data, you need to process them, right? The job of a software engineer would not change, but your tool will evolve. Your job for a long time is going to be taking specifications, convert that into executable programs. That's going to be your job for years to come. Okay, this won't change. Your hammer may be different, become bigger and bigger and better and better, but it's going to be still largely doing the same job. Actually, your foundation, your computational foundation, wouldn't change for a long time. It's still going to be a state machine. The Neumann model has been criticized left and right, but still the dominating model. Basically, is instruction out, instruction in, result out. Okay? Your CPU take the instruction in, that's your output. That's the same idea with our computer, data in, result out. Data processing systems, ML systems, decision-making systems, your chat app, the same thing. Okay? That won't change. So all these, it's important to look at what project you're doing, development team or management team. So I think this time it's certainly going to change how Boeing develop their software. I think they're going to certainly need to hire a lot more people who are capable of doing more formal programming analysis, so that their program can be more reliable. They'll actually change what kind of analysis techniques they're going to use. Would this affect you much? If you're not joining Boeing, this is probably not going to affect you much, right? But if you're becoming an engineer in Boeing doing software development, particularly those goes on to the aircraft, yeah, you actually go to see the impact. In terms of testing, still the same thing. Essentially, you're doing inspection. Inspection is just a glorified version of you read the code, read the document. In this case, mainly the documents, right? For instance, how do I grade your project at this time? I go read your documentation. Is there any better way, guys? Except that I just give you a grade. No, there is none. There's really nothing that's better than I go read your document. I can find a grader or project manager to read your documents, but still some human being need to eyeball your project report, your requirement, your design, your test plan. Boom! Until you turn into the final code, then I have something different. That's the time I can actually go execute your code. Okay? That's when things change. When I can actually run your code. That's the only time your testing method is not limited to inspection anymore. It's become executable, execution-based testing. Okay? Even then, your inspection wouldn't stop, right? Code review is so popular nowadays in industry. Everybody's doing code review, right? Because code review is important complementary technique to your execution-based testing. Just by execution-based testing, you may actually leave out many of the bugs. Inspection is as useful as your execution-based testing. That's why people are doing a lot of code reviews. You can't even check in code in a normal company. Unless you're in a startup, no, you don't really have people. In that case, you're checking any code you want, right? But most of the company, before you try checking code, you have to get your code reviewed. What is reviewed? I mean, you can say it's inspected, or you can just say people eyeball your code. That's it. So there's really not much different thing we can do today. Then I look at your code. I look at your documentation, right? So I don't have a better way to grade your project, right? Simply, I mean, same way as your manager in the industry has no way to grade your performance unless he or she look at your code and documentation, right? The same way, your colleague and everything, same way, right? Because right now, fundamentally, in terms of testing, we have execution-based testing and inspection. I mean, certainly you can have tools to help you do inspection. For instance, our linting tools, our static analysis tool, and all these great things, and flooding tools, and so forth. However, these are limited. I mean, you basically, the fundamental thing, fundamental baseline is still people look at code. These tools to help you to look at code faster, a little bit faster. It's not changing the way you do it, just make it shorter and faster. All right, so here, tools for classical analysis and for object-oriented approach. At this point, actually, you don't really need many more tools. What tools have you used in my class for project, for homework, for quiz? What tool have you used so far?
Lots of different things. Use the IDE.
IDE. Yeah, if you decided you are going to earn that credit for implementing my final project, you need that IDE. What else?